With number 1, it says using the word aardvark. First thing we do when we get a word, we know it's a permutation, because order matters, right? Words are permutations, codes are permutations, phone numbers are permutations, license plates are permutations. Lining someone up in a picture is a permutation. Lining someone up in a row to buy tickets is a permutation. Arranging people in a picture is a permutation. Arranging books on a shelf is a permutation. Arranging pictures on a wall is a permutation, because you're giving them jobs, you're giving them spots, right? Yeah. Yeah. So combinations come when you have a subcommittee of 5. You can fill in here. Yeah. Subcommittee of 5 people, and they're either on the committee or they're not, and they don't have jobs, or they're not doing anything special, right? Or principals from principals, teachers from teachers, students from students, boys from boys, girls from girls, puppies from puppies. If you do anything like that, it's a combination, because you're choosing from that same group and you're not giving them jobs, right? And it's 2 terms and comms. So we're going to look at number 1, using the word aardvark. Determine how many distinct words can be formed using all of the letters. So we have to pay attention, because sometimes we only use 3 of the letters or 4 of the letters. Here we're using all of the letters in aardvark. So I'm going to go to a separate page just so I can write on it. So A, R, D, V, A, R, K. Right? So I immediately go to the bottom and I go 3 factorial, 2 factorial before I even ask the question. Then the question says no restrictions. No restrictions means I just take the number of letters and put it on top, factorial, right? How many letters are in aardvark? 8. So it's 8 factorial divided by 3 factorial, 2 factorial, which is? Then we have B. B says the word begins with a and ends with a consonant. How many consonants are there? 5, because consonants are just not vowels, and there's 3 A's, right? Before I go do the question, I'm immediately going to go 3 factorial, 2 factorial, because there's no question. If there's 3 A's and 2 R's, I'm putting 3 factorial, 2 factorial on the bottom. On the top, I have 1, 2, 3, 4, 5, 6, 7, 8 blanks. How many options do I have for the first blank? 5. Then for the last blank, why is it going down by 1? Because you're leaving a letter behind. Yep. How many letters have we used up now? 2. How many do we have left? 6, 5, 4, 3, 2, 1. And what can't we forget to do? Multiply. And we can sum this up as 5, 4. So we can go 20. 5 times 4 is 20. Times 6 factorial, because I can go 6, 5, 4, 3, 2, 1, blast off like a rocket. Divided by 3 factorial, 2 factorial. And what do you get for this one?
2,360. Oh, wait, sorry.
No. I'm like, that was the... Sorry? Now, we could have went 5P2 for the 5-4, couldn't we? Technically, if I have 5 times 4, it starts at 5. P, it goes down by 1 each time, correct? And how many blanks are there? 2. So I could go 5P2. Remember the P you can use as well. I'm not saying 2 use it, but I just want to remind you of it. C says the vowels must be together. How many vowels are there in aardvark? 3. Immediately I go 3 factorial, 2 factorial, because aardvark has 3 A's and 2 R's. I'm going to hook my 3 vowels together. 3, 2, 1. Why do I treat them like 3, 2, 1 when they're all A's and I flip them around, doesn't change anything? You're worrying about it at the bottom, that's getting rid of it. So we just treat them like they're all different at the top, right? How many letters do I have left? 5, 4, 3, 2, 1. Did it say the vowels have to be at the front? Just says they have to be together. So I have to multiply by 6. Because there's 6 ways I can move it. It's always one more than the number after they're hooked together. So I get 3 factorial, 6 factorial over 3 factorial, 2 factorial, which is 360. Then I have V. D says the vowels cannot be together, and there will be one of these on your test for sure, right? I've given it to you almost on every single quiz. It's a standard of excellence question when they can't be together. There will be something like that. It might be people not being allowed to be together, or it might be letters not being allowed together, but there will be a test question where you're not going to be allowing to leave something together. So what do? Total no restrictions, which we did at the top. This one, 3360. That was all the different ways I could rearrange aardvark, right? So it was total no restrictions. And what do I have to subtract off of it? Vowels together, right? How many vowels are there when their vowels are together? How many cases? 360. We already did it. So our answer's 3,000. And I can ask this the same way as if I'm making people stand in a row, right? And then I say these two get in a fight and they can't stand together. It's the same thing. I just won't get the factorials underneath because I won't have repeating letters because it's just people, right? All right, number 2. A committee of 15 people, go back to here so we can read it. A committee of 15 people with 11 boys and 4 girls wants to form a 5-person subcommittee to help plan the end of the year school dance. How many committees can be formed? Is this a C or a P? C, because I look at that subcommittee and I say they don't have jobs. There's nothing special to be picked first, second, third, fourth, or fifth on that subcommittee. You're just on it or you're not. So it's a C. What's the cool thing about C's? If I went 21C3, what does that equal? 21C 18. Remember, you can, when you use the C formula, you can go 21C3 equals 21C 21 minus 3. Remember, they equal the same. That's only with the C formula. Also, C's can be represented by the brackets, right? That's with C's. A little reminder. So here we have a 5-person committee with no restrictions. So I have 15 people, 11 boys, 14 girls. A says no restrictions. So what do I choose from? How many people? You just take 15 because I don't care if they're boys or girls, right? There's nothing but boys or girls. So I'm going to do 15C5. How much is that? 3,003. B says exactly 2 girls. So 2 girls. People will say 4C2 and give me that answer, which is not right because my subcommittee needs to have how many on it? 5. Just like if I did a 5-card hand, right? And it said 4 queens. I would have to add 1 other, right? Card hands, those come up too in tests. So remember that you have to always have the 5-card hand, or in this case, you have to have the 5-person committee, right? Right now I have a 2-person committee. So I need 2 girls and 3 boys. So I know if I go 2 girls and 3 boys, I have a better chance you guys are going to get it right. But if I go 2 girls, you might just go 4C2 and forget that you need to have 5. So it's going to be 4C2 and means I multiply 11C3. What do you get for that? 990. C said at most 2 boys. This is cases. At most or at least is cases. So if it says at most 2 boys, we need 2 boys or less. And we can think about it as money. At most $2 when I walk into a store, I need $2 or less. And the or less cases make you go down to 0. Don't forget the 0 case. Everyone forgets that, and they'll have the answer without it. So I need at most 2 boys. So I need 2 boys or 1 boy, or I have to not forget the case of 0 boys. So the at most cases always have a 0 case. Yep.
Wouldn't in this case it wouldn't work because you have to have 5 people on the committee but it's only 4 girls.
So we have to watch. We're going to have to kick out a case. Yep. So we would fill in our things. And then here we're going to go 2 boys and 3 girls. or 1 boy and 4 girls, or 0 boys and 5 girls. So people will do this, okay? Then we would go, I have 11 boys and 4 girls. So I'm going to go 11C2 times 4C3 plus 11C1 times 4C4 plus, we'll kick out the 0 case because I don't care about that, and then they go 4C5, and they type it into their calculator, and their calculator yells at them and says error, 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 and you're like, okay, I just did it totally wrong. You didn't do it wrong, but what do you know about N and R for NCR? Or equal to. N has to be greater than or equal to R. So this was okay, 4C4 was okay, because what are you doing when you're saying this? You're saying, I have 4 girls and I'm choosing 4. Here you're saying, I have 4 girls and I'm choosing 5. Does that make sense? No. So this case actually gets thrown out because it doesn't work. So we do 11C2 times 4C3 plus 11C1 times 4C4, and what do you get? You might have just added an extra case at the end to get the extra one. D. D says at least 3 girls. So I need 3 girls, or 4 girls, or 5 girls. People will do again. Can I have 5 girls? No. Nope. So this case is out. So I'm going to do 3 girls and 2 boys, or 4 girls and 1 boy. What is this? It's the exact same case. It's just asked differently. Right? 2 boys, 3 girls, 2 boys, plus 4 girls, 1 boy, 4 girls. I just gave you the exact same question asked with an at least or an at most difference. That's it. E. All subcommittees, all of the subcommittee members must have different jobs. What's the change? Now it's a permutation. Does it say anything about boys or girls or anything? Nope. So what do I do? 15 P5. And what's that? 360?
360,000. No.
Oh, 360,360. I was like, that was a really small number, and I didn't believe it, but yeah. No. I was just like, 720? I got that. Okay, keep working. Number 3, I threw in here because people forget about it. I'm just going to do it right on here. At a baseball tournament, there are 15 teams, so that's how many you choose from, right? That's your N. Kyle? No. Then, how many different games will be played if everyone plays each other once? So the thing we have to remember is we have 15 to choose from. It's a C because we're not going to use home and away, right? We're just going to use them as different. Home or away makes one game. And we're choosing how many teams to play each other when we play baseball? 2. So that's once. So what do we get for 15C2?
105.
It's like 30. Okay. And then if they play each other once, we just multiply by 1, which does nothing. If they play each other twice, we do the same thing but times it by 2.
Wait, are you podcasting right now?
Yep. I believe.
Is your mic on though? That's a real question.
Yes. It's a good day today. Okay. 15C2, which is 210. And then 3 times we do the same thing, which times by 3. 15C2, which is 315. A circle has 8 dots on the outside edge. How many different triangles can be made using the circles as vertices? So, we have how many dots to choose from? 8. We're going to choose how many at a time? 3 because it's a triangle. Does the order matter in which I pick those dots? Does it make a different triangle? Nope. So I'm going to use what? Yep. If you guess both, you will be right no matter what. 8C3 is what?
56.
don't know whether to trust you or
No,
not.
that's right.
Okay, when he says stuff, sometimes it's totally up to lunch, sometimes it's right. No, he just does it sometimes, like 30. In a room, there are 20 people. Everyone must shake hands with everyone else. How many different handshakes are possible? So we have 20 people, and we choose how many to make a handshake? 2. Is it a C or a P? And the answer to this is? Number 6, using a standard deck of 52 playing cards where 5 card hands are dealt. So this is like a 5-person subcommittee without jobs, right? 5 card hands, same thing, because what's the first thing you do when you get the cards in your hand?
Look at them.
Yep, I forgot that's how you guys answer this. Only class ever who said look at them first. Look at them, yeah, and then what do? You arrange them, you move them around. So if you can move them around, order doesn't matter, it's a C. So you're not wrong with that, it's just strange. So we have 2 queens. We must contain 2 queens. Is the hand done? What do I have to do? And 3 what? Others. They have to be other than queens. So how many queens do I have to choose from? 4 C2, because order doesn't matter. And is multiply. 3 others. 58, take away 4. So it's 48, choose 3. Remember, you just take off this number, because you can't have those ones. Or else you could possibly get 3 queens or 4 queens. We just take that number off of the total, which is 52, and use that. Did anyone get the answer to that? Yeah.
103,776.
The next one is going to be a case question. I'm just going to do it down here just so we can still see it. So I need at most 1 black. So that means I need 1 black or what? 0 black. Because at most means I can work my way to 0. At least means I work my way to how many I can have, like 5 in this case. So at least I work to 5, at most I work to 0. So 1 black, I need to supplement this with 1 black and 4 red, 0 black and 5 red. Or you could say 5 others, it would be the same thing, right, other than black. So here I'm going to have 26, yeah, not 13, someone just threw me up. 26, choose 1, times, then this one I do 52 minus this off, right? 26, which is 26, C4. Or means I add, do I have to include the 0 case? No. If I include it, am I wrong? No. If I went 26C0, it would just give me 1, and 1 times anything is just whatever the heck the other thing is. So you can include it or not, it doesn't matter. I'm just going to exclude it, and I have 26C5. Did anyone get the answer to that? Yeah.
400,054, 480.
454,480?
Yeah.
Perfect. Okay, C says at least 3 spades. So at least means I'm going to the highest I can go to, right? Which is 5. So I'm going to do 3 spades or 4 spades or 5 spades. And then I'm going to supplement. So I have 3 spades and 2 others. 4 spades and 1 other. Or 5 spades and 0 others. So I don't need to supplement that one because there's a 5 card hand. How many spades are there? 13. 13C3, there's the 13 came up in handy at some point. Times 2 others. So all I do with the others is I do 52 and I subtract off this number always. That's going to be 39. Choose 2. Plus 13C4 times 39C1 plus 13C5. Anyone get the answer to that one? 241,98.
1,000.
And D says one queen and 3 kings. And people will figure this out, but what's my problem? I'm missing a card, I need 5. So 1 queen and 3 kings and 1 other. And the other in this case is, can't be a queen or a king, right? How many queens do I have to choose from? 4 and I choose 1 times kings. 4 choose 3. Now the other cards can't include these ones or these ones, right? So it has to be 52 minus 8, which is 44. Choose what? What'd you get? Number 7 says, how many odd 6-digit numbers are there without repetition? Odd 6-digit without repetition. So that means I have 6 blanks. What does odd mean?
1, 3, 5, 7, 9.
It's what I need to end in. Yeah, 1, 3, 5, 7, or 9. So I have 5 options. This said no repetition though. Whenever it says no repetition, what do I need to do? Box and hold. So I'm going to hold the 9 here. Then here I have 1 to 8. What can't it be here? 0. So that's only 8 options. Then I hold the 8. Then what's this one? 1 to 7. I have to remember to bring that 0 back. That's where you're going to get burnt on this question, remember? Because I didn't use the 0 in the end because it would make it even. I didn't use the 0 at the front because it would make it a 5-digit number. So the 0 has to come back in the second blank. So that's 8 options. Then I hold the 0. So then I have 1 to 7, which is 7 options. Hold the 7. 1 to 6, 6 options. Hold the 6. 1 to 5, 5 options. Make sure to put the multiplication dots. What's 8 times 8 times 7 times 6 times 5 times 5? Wow.
One question.
Yeah.
If you don't put the multiplication dots, you lose marks.
Yeah, because if you don't put the multiplication dots, that's 887,655. Right? If there's no multiplication dots, that's a 100,000. That's all it is. Anyone get it? Yeah.
That's 7.
Number 8, we'll go through. And then the back page, I'm going to go through on the recording, right? So before your test on Monday, you want to go through the back page and then watch the recording. It's going to be all in one recording, right? So you'll have to speed through this part, which is fine. And watch the back of this recording, right, for this handout. Yeah?
Can you post the answer key to the sheet?
No, I'm going to post the recording to going through these. So if you want to see the answers, you're just going to have to go watch them. Number 8. Number 8 says, Jeremy, Jesse, Jamie, Amy, Lori, and Crystal go to the movies. How many different ways can they be seated next to each other in the movie theater if? These are all my brothers and my 2 sister-in-laws. Well, not all my brothers. And not all my sister-in-laws. Boy. Jeremy, Jesse, and Jamie are boys, and me. Amy and Lori, my sister-in-laws. I excluded one sister-in-law and my husband. Okay. So there are no restrictions. If there's no restrictions, how many ways can I rearrange them? Yeah, 6 factorial. Just put 1 in each blank, right? B, this is where people are going to make mistakes. The boys and girls must alternate. Watch this. where you're going to error. So I could start with the boys, and then I would have 3, 2, 1, girls, 3, 2, 1, which is 3 factorial, which is the answer that everyone's going to give me. But what do I have to remember that I can do? I could actually start with what instead? I could start with girls. So it's going to be the same answer. So all I have to do is take this answer and times it by 2. So it's actually 72. So the second half of this page, you need to accomplish before Monday. If you don't, that's on you. If you don't, it's on you. The test is on Monday. Okay, for number 9, we're going to treat it like down, 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 right, 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 like the word der. Remember this? So it's D, 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 R, 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 R. So how will we make that word? Well, it's 10 letters. So we go 10 factorial divided by 5 factorial for the D's, 5 factorial for the R's. Now we need those paths and we need the other ones. So we're going to multiply D, 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 R, R, R. So we're going to do 8 factorial over 5 factorial, 3 factorial. Now when we type that in, you're going to get 10 math. Factorial divided by 5, math factorial 5, math factorial in brackets, 252 times 8 math factorial divided by 5 factorial 3 factorial 56 equals 14,112.
Good afternoon, staff.
Now for 9B, you're going to do D, 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 R, 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 which is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 factorial divided by 3 factorial, 11 factorial. Because there's 11 R's, times D, 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 R, R, 5 factorial divided by 3 factorial, 2 factorial, times D, D, R, 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 R. So that's 2, 3, 4, 5, 6, 7, 8 factorial divided by 2 factorial, 6 factorial. So we get math. (14 factorial divided by 3 factorial 11 factorial, which is 364, times 5 factorial divided by 3 factorial 2 factorial, which is 10, and then we get 8 factorial divided by 2 times 6 factorial, which is 28. So we get 364 times 28 times 10, which is 101,920 counts. And we go to 10. How many 3-digit numbers less than 700 can be created using the digits 1, 3, 4, 5, 7, 8, 0 if repetition is allowed? So less than 700 means I can only start with 1, 3, 4, and 5. I can't start with a 0 because it would be a 2-digit number. So I get 4. Then I can bring all of them back. 1, 2, 3, 4, 5, 6, 7 of them. So times 7, and then times 7 again. So I get 4 times 7 times 7, which is 196. The next one, if repetition isn't allowed, I go 1, 3, 4, 5, which is 4. I box and hold the 5. So now I would have 6 for this one, and then I hold one there, so then I'd have 5. So it's 4 times 6 times 5, which is 120. 11. Give me every different way you can represent the situation. There are 32 students in Mrs. Lepp's Math 30-2 class. She's randomly choosing 6 of them to go on a trip to 7-Eleven. How many different ways can Mrs. Lepp do this? So she isn't giving them jobs, so I can do 32C7, or I can go 32-7, because see, I can do that. Or, remember, I can subtract them. So I can go 32C, 32 minus 7, which is 3225, which equals 32 C25 or 32 over 25, and 32 math C7 is 3,365,856. So that's for number 11. Number 12, NCR and NPR you have seen in this unit. Compare the two formulas. NCR formula is n factorial over n minus r factorial r factorial. The NPR formula is n factorial over n minus r factorial. So when we compare them, the NCR formula is just the NPR formula divided by r factorial. That's it. They're the exact same, except NPR is divided by r factorial to get NCR. So you'd have to write that. I just don't have room. Number 13. 100 people enter their name into a draw to win 3 prizes. How many ways can 3 prizes be drawn if all the 3 prizes are the same? If they're all the same, then it doesn't matter what order you get them. You're going to get the same prize whether you're first, second, or third picked. So that one would be 100 C3, which is 161,700. If all 3 prizes are different, the order in which you get them matters, because if one of them is a trip to Honolulu and the other one is a fork, you're going to want to win the trip to Honolulu. So order matters if they're different prizes. So NP3, 100P3 is 970,200. So substantially more options because order matters. Number 14, a Powerhouse Committee is being formed from a school division made up of 25 principals, 250 teachers, and 8,000 students. They are wanting to form a subcommittee to discuss issues throughout the school division. They are wanting a 12-person subcommittee. Does it say they have jobs? Nope, so it's a C. How many subcommittees can be made if there are no restrictions? Well, then we're going to take all of them. We don't care what they are, principals, students, teachers. So I'm going to go 25 plus 250 plus 8,000, and I have 8,275 people to choose from, and I'm choosing a 12-person subcommittee. And that is really large, so we're just going to leave it at that. There must be 2 principals, 3 teachers, 7 students. That's 12 people, so I've covered my 12-person subcommittee. How do I guarantee principals? Getting principals from principals. So I'm going to go 25 C2 times teachers 250 C3 times 8,000 C7. And they're not going to make you do these because they'd be giant numbers. So they'll just let you keep it like that. Now there must be 7 students. That's great, but I need 12 people. So I need 7 students and 5 others that aren't students. So students, there's 8,000. So I'm going to do 8,000 C7 times the others. The others are 250 teachers and 25 principals. So 275 people, and I'm choosing 5 of them. Then for D, it says there must be at most 2 principals. So that means 2 principals or less. So I could have 2 principals or 1 principal or 0 principals. Then I have to supplement with others. So 2 principals and 10 others that aren't principals, 1 principal and 11 others, or 0 principals and 12 others. So how would I put that in? I'm going to do it over here. And I'm just going to write it right here. So principals, there's 25, and I choose 2 times 10 others, not 100, it's 10 others. 11 others, 12 others. So others are 8,250, so 8,250 total, and I'm going to choose 10. Plus 25 principals, and I'm going to choose 11. Oh, sorry, choose 1. Oh, and 8,250 others, and I choose 10. Plus, I need 12 others. So 8,250, choose 12. And like I said, you're not going to type these in your calculator because they would be massive. They would just leave them that way. The next one says, Jim decides to line up some cars at a dealership. He has 12 cars in total, 6 black, 3 gray, and 3 blue. Determine how many ways the cars can be arranged if they're different models, which means they don't look alike. So I'm just rearranging them. It doesn't say I have to start with a black or end with a gray or the blues have to be together. So I would just take all of the cars, factorial, which is 479,001,600. Now, if they're the same model, that means I have identicals. It's like having 6 Bs, 3 Gs, and 3 other different types of Bs, B2s. So I have to do 12 factorial just like I did before because there's no restrictions on where the cars are, but I have to divide by 6 factorial, 3 factorial, 3 factorial. So I get 12 factorial divided by 6 factorial, 3 factorial, 3 factorial, which is substantially smaller because we get rid of all those cases where they're the same. The last question, a menu consists of 4 appetizers, 5 main courses, and 6 desserts. How many ways can you pick a meal made containing 1 appetizer, 1 main course, and 1 dessert? I told you when it's 1 of each, you can literally use fundamental counting principle, which would be 4 times 5 times 6, which is 120. However, if it's not 1 of each, so in this case 2 appetizers and 2 desserts, I told you have to use C. So we'd go 4 appetizers, choose 2, because we're doing appetizers, appetizers, main course, dessert, dessert, just like principals, principals, students, students. So I'm going to do 4, choose 2, 5 main course, choose 1, and, so they're multiplying, 6 desserts, choose 2. So that is going to get you 450 different meals. And that's it. So please make sure you review before your unit test on Monday. You can go back and do any of the questions or quizzes that I gave you before. Have a good weekend.